All right, so good morning, everyone. Let's get started with our Scala program today. So, we are going to talk about Scala, right? We will go in detail. We will understand all the functional programming of Scala. We'll try to understand how they are really different than Java. We'll do a lot of hands-on, and then we'll also get started with a project, right? So that's what the whole agenda of Scala. This would go for at least 2.5 months or probably 3 months. We have a curriculum of 60 hours. So we'll go step by step. Okay. Now let's get started. So I would be basically focusing on discussing this Scala with respect to Java, right? So let's understand a little bit about Scala now. Okay. So I'll say Scala, right? And you may ask me what version we are going to cover in this program. We'll be covering 3.x. It's really new, right? So recently launched 1 month ago, and like while we are doing this, we'll also do 2.x as well as 3.x. 2.x is widely used in the industry, but we'll also start with 3.x so that we can understand what are the new things that has really come up in Scala 3.x. Okay, now Scala, right? So let's go with the documentation as well. I'll be referring my documents while I teach you so that I don't miss any single topic. Okay. So Scala is a programming language just like your Java. Okay, and it was introduced in the year 2004. Okay, it was introduced in the year 2004 by Martin Odersky. Martin, let me check the spelling. Odersky. Okay, so Scala is a programming language which was introduced by Martin Odersky in 2004, right? And if you remember, Java is currently, industry uses 1.8. We will stick to the same. The recent version is 15, 16 is available, but then industry prefers 1.8, so we'll stick to the Java 1.8 version. Okay, and Java was introduced in 1995 December, or as per the Wikipedia, it's 1996 January. Okay, and it was invented by James Gosling. Gosling. James Gosling. Okay, so it's James. Yeah. What is the difference, right? So we will start with the difference between these two and why actually the whole world is now going around and then starting writing a programming Scala, right? So we'll understand the basic fundamental of Scala. We'll understand what makes it more better than Java. Why should somebody prefer Scala over Java? Okay, so number one, so we all know that Java is doing really great in the industry, and it is really doing a lot of, we are actually working on many different projects in Java since a long time, right? So you can assume, like, right, it's 1995, so almost you can say 20 years plus, right? People are using Java a lot, right? And a lot of programs, a lot of projects are being developed in Java, right? Now, if you look into the industry 5 years down the line earlier, right? So let's in the year 2015, right? Most of the projects were actually built on Java. Okay, most of the projects were built on Java, right? Why? The reason was there were a lot of reasons, but main reason was platform independent and open source. These were the two reasons why Java was quite popular, right? So why platform independent? Okay, platform independent, and other one was open source, right? These were the two reasons that Java picked up very quickly. And then since it was open source, there were a lot of people contributing in the development of Java, and Java became quite successful than any other programming language. I'm not sure if you know it or no, but then let me tell you that Python was the initial version of Python was released somewhere around 1990. Okay, so what I'm trying to tell you is Python is quite older language than Java, right? But then Python was not that popular till last 5 years when people started working on data science, right? So Python has become really very popular these days, all because of data science projects, right? Otherwise, people were still comfortable using Java rather than using Python. Right. So that's what we wanted to highlight here. Python is quite older than Java, but still Java is ruling the market. Now you may say, okay, I understand that Java is ruling the market, but then why exactly Scala, right? What is wrong with Java, right? So there is nothing wrong with Java, but then the problem was, number one, Java was verbose. Okay, when we say verbose, what does it mean? It means you will have to write a lot of code to get the things done, right? And trust me, if you have done a lot of Java development in your career, I'll give you guarantee that once you master Scala, you will feel very, very lazy to do the same work. Okay, you'll say, I would not prefer Java anymore because I can do the same thing using Scala, right? Now the question is, okay, we know that Python is easy. We know that Python is easy, okay? And then it can help me to do the work by just writing less code, right? Doing the same work, right? Now let me tell you, Scala can also do the same thing for you. Scala can also do the same thing for you what Python is actually doing, right? You can write a small code, you can write a short code, short and precise code, and still get your work done. Okay. Now the biggest advantage would be if you are using Scala programming, right? So you see Scala is another way to program your JVM, right? So what is a JVM, guys? JVM stands for Java Virtual Machine, and it is basically, I would say, an environment which can be used to run your Java code. It's not it. So like you write a Java program, right? Usually we write a Java program. This Java program is compiled by whom? Java compiler. This Java program is compiled by Java programmer. Now, once this Java program is compiled, this gives you what? Dot class file, right? And this dot class file contains what? Instructions. We call it a bytecode, right? So this bytecode is basically what would be consumed by your JVM. So Java Virtual Machine, they understand only bytecodes. No matter who gives them bytecode, it does not matter. But if you give bytecode to this guy, it will be able to understand and it will be execute all the instructions whatever you have written, right? Now similarly, you can use Scala, okay? And what you will do is you will write a Scala program, right? Scala program, I'll say program, and this program would be compiled by your Scala compiler. Would be compiled by a Scala compiler, and the Scala compiler is going to convert your dot Scala file to dot class file. So what we understood here is, no matter what is your compiler, right? Your compiler is Java compiler or your compiler is Scala compiler, all of them produce the same dot class file, and this dot class file would be consumed by the same JVM. Okay, what does it mean? That means as a programmer, it does not matter whether you write a Java code or whether you write a Scala code. At the end of the day, they would be compiled to a dot class file. And once we have the dot class file, it's all same, right? The JVM will be able to understand it very happily and it can execute whatever you have written. Okay. Now, can you give me one example of this, right? So let's take an example. Suppose you might have seen, a lot of journalists, right, who basically go out in the field to take the report of a minister or whatever, right, of big personalities. What do? They basically know one more language called shorthand. I don't know if you know it or not, but then it's worth understanding. These people know a language called shorthand. We also call it steno. STENO, stenography. Okay, so they basically know a shorthand, which is basically a stenography, in which what they do is whatever the ministers or personalities are speaking, they are able to write it very, very fast, really fast, right? For example, it says A, you don't have to write A like this, you can just write like this. And like there are some symbols. I am also not mastering it. I was just doing some beginner level of codes out of my curiosity. But then shorthand is basically what these people are using. Okay. Now the idea is, if I go to take the report and if a journalist goes to take up the report, right? The difference would be I will take a lot of time to write the same thing. But that journalist, because she or he knows the shorthand, he or she would be able to write it very, very fast, right? Write it very, very fast. And then when we both go to the office, then, like when we both go to the office, then probably I might have missed a lot of information, probably, or, I have written a lot of lengthy description to explain what was discussed in the meeting or all together, right? So what I'm trying to tell you here is the shorthand is basically your Scala, wherein you write a small code. The syntax would be small, doing the same thing. Okay. Whereas your Java is basically the normal writing. You write a lot of lengthy code, and then you write, like a lot of methods and all, and that makes your Java really verbose, right? There is no harm using Java. People are still using Java, but the only point what I'm trying to highlight here is Java Scala will make your code much more precise and will make your development faster without impacting the quality of the code, right? Because see, people, the industry is like habituated with JVM, right? The industry is habituated with JVM, and let me tell you one thing, guys. All the best product of a company are all still written in JVM based language. Okay, you may not agree with me probably because you are a Python guy, but that's okay. But let me tell you honestly that all the big projects, whatever you see, whatever you can you see in the whole world, right? They're all written in Java and JVM based language. Okay, and what is the reason? The reason is because of two, three things, right? Platform independent. Number one, because see, for the development, we always use Windows. We all know that, or maybe you'll use Ubuntu, or maybe you'll use your Mac. It really does not matter, right? But then when you are deploying this solution into a server, right? Most of the time, what happens? The server version may be different. Somebody might be using Red Hat Linux. Somebody might be using some other flavor of Linux system. Somebody might be using Unix boxes, right? And they need a platform independent system, and that is the reason JVM is much more preferred. Okay. Now let us talk about the feature of Scala. What exactly makes your Scala really beautiful? Okay, so I'll also be referring my notes in the middle so that I don't miss any point because it's very important. Okay, so if you see this word Scala means what? Scalable language. Okay, so if you want to break this down, this word Scala, you can say scalable language, right? That means Scala is actually designed uh, to serve a lot of industries, and it said like I don't really care what is your requirement. Scala should be in such a position that it should be able to program anywhere. You should be able to program Scala almost everywhere, right? So wherever you see Java, you can happily use Scala without any second thought. One more thing I want to tell you, a lot of libraries and APIs are available in Scala, which is far beyond than Java. You cannot really imagine as well. Once we start understanding Scala in more detail, you really appreciate the way people have designed Scala, right? So they have come up with a lot of libraries, which makes your life much more easy. So I'll give you just one example so that you understand that the power of Scala is. Now let's take a couple of example, okay, where I'll try to explain you what actually you do to write a code in Java and what exactly you have to do to write the same code in Scala. Okay, I'll start with Java first. Okay, so the requirement is, let's say, create a class called employee, public class employee. Okay, and let's have two fields, that is employee ID. So I'll say employee ID, okay, and employee name. So employee ID would be of integer type, a name would be of string type, and most likely we make it private. Right? And then since it's a private variable, so you will not be able to access them outside. So what do you need? You need a setter method, you need a getter method. So you will say set employee ID int emp id, and this is a set method. So you will say public void right, and then you will say this dot employee ID is equal to employee ID. That's what you do, right? To write a setter method. So once you have written a setter method, let me also write one getter method, public int. It's a getter method that should return a value, get employee ID. Okay, and then you will say braces and you just say return employee ID. Okay, this is what basically you will do if you have to write a employee class. We call it a Java bean. Okay, Java bean is basically a class with some properties. We call this properties, right? And this is your set method, and this is your getter methods, right? So for employee ID, I created one setter method and one getter method. Similarly, for employee name, I should create one getter method and setter method, right? And then you can have a constructor, you can have a toString method, you can have a hash code method, and all those stuff. So you have to write at least this much code, okay? Or even if you may say, hey, we will be using ID, of course, and then ID is capable enough to create all this logic, right? So all you need to do is just have these two property and then right click somewhere. You will be able to generate your getter and setter methods, constructors, toString method, whatever is required. We'll see that when we start practical, right? But then still you still have to produce this much of code. Either you write it or you make your ID writing that for you, but still you are producing a lot of code, right? Which is really not a great idea. Okay. Now Scala, if you are trying to achieve the same thing in Scala, all you need to do is just write case, class, okay, and employee, right? And then what are the variables here? Employee ID and employee name. So I'll say employee ID. What is the type of it? The type of it is integer. So I'll say int, comma, okay, and then employee name. So I'll have employee name. What is the type of it? String. Okay, done. All you need to do is you just need to write this single line of code, and once you write this, your private methods, your setter methods, your getter methods, everything would be automatically generated, not here in the code, while it creates a dot class file. Okay, here if you see, all this code has to be generated in your .java file, right? And that would be compiled by your Java compiler, and it would convert that into .class file. But Scala is smart enough. It says you just give me this, and this is just a one-line code, right? So you just give me this, and my Scala compiler will compile it to the JVM bytecode. Okay, and this bytecode and the bytecode produced from this file would be same, ditto same, A to Z same, right? That is what is the beauty of your Scala. You just have to write a small line of code. Now think about it, even though you're writing this much, it takes a lot of effort and time, right? This is what your Scala can do for you. It makes your code short and precise. And trust me, many times when somebody says, Suraj, we have to work on a project, and unfortunately that project is written in Java. Trust me, I feel a lot of pain, because I really don't want to go back to that language where I have to write a lot of code still producing the same thing. And I'm like, can we do it in Scala, right? Or can we create a library in Scala and then we will put it on the Java project and then we'll just consume? Because I really started hating the way the Java coding was written. Okay, because you have to write a lot of stuff, and I don't want to I don't want to spend a lot of time writing the same old code. What I can do it in a single line. Okay, so this is one such example. So it's just one example here, right? And then let us move forward. We'll understand one more example. So I'm just trying to welcome Scala in our program. But trust me, I still love Java, because I've been doing Java programming since 16-17 years. I started Java programming when I was just I think 14 years. Yeah, and then since then I am now 31, so 14 plus 31 is 17. So I've been doing Java programming since 17 years. I still do Java whenever there is a requirement, whenever there is a small piece of code to understand. But if somebody says, given a choice, what would you prefer? I would always prefer Scala. Okay. Let's take one more example to understand what could be the difference between a Scala and a Java. Now let's take one more example. Suppose I have an array. I'll say int array of some number, say 5, 7, 2, 1, 0. Okay. Now the requirement is very simple. I want to find out the sum of all the elements in an array. Right? I want to find out the sum of all the elements in an array. How are you going to do this? You would probably say, I'll create a variable int total sum equal to 0. Right? Don't forget this p, this semicolon. It's a sen, right? So int sum equal to 0. You'll use a loop now, right? For, so we are talking about Java now. You'll be using a loop, as you'll say for int I is equal to 0, I is less than equal to array dot length, right? So what is the array dot length? 1, 2, 3, 4, 5. So 5. So you should say like this, less than that, right? And then I plus plus. You write it like this, and then you'll start iterating through this loop. It's not it. You'll start iterating through this loop, and you will say sum is equal to sum plus array of I. Right? You'll write it something like this. It's not it. Now, when you do that, what happens? This is an array which has some elements. We started a loop, right? And every time I'll get I value is equal to 0, 1, 2, 3, 4, and I'm fetching that value and constantly appending them under my sum, right? That's what I'm doing. And finally, once this for loop is over, right? You can say SOP sum. And what does it give you? It gives you the actual sum, right? So 7, 8, 9, 10, 15. So it should give you 15. Is not it? That's how you basically do it in Java. You may say, hey, we have one more enhanced for loop. Why don't you use it? You can use that also. You can say for int num from array, right? And you can still say sum plus equal to num. You can also do this. Okay. Same thing if you ask me. Now the biggest pain point here would be you are actually maintaining a variable called sum, right? You are maintaining a variable called sum, and then you are using a loop. Okay, you may say what's wrong? That's what we are doing traditionally even in our C programming. But let's talk about the Scala approach. Scala says you have this data array of the same number, right? All you need to do is you just say array dot reduce, okay, done, and you say total. You're done. You're literally done. And you may say, what is that symbol? Underscore plus underscore. We'll talk about that. Don't worry, right? Even if you don't understand a lot of stuff here, that's okay. It takes little time for us to understand the language, right? So right now here, I'm not here to teach you what is that underscore plus underscore does. We'll look into that in great details. What is this method? We'll learn that in great details. But right now, I'm just trying to explain you what can you do in Scala. Like what is the difference between the Scala and Java? What you are writing literally a big code in Java, the same code can be written in a very short way, right? That's what we do. Now you may say, now I may have another requirement. Let's say all the numbers which are even. Okay, so the requirement is very simple. Find sum of all odd numbers given in array, right? So see here 5, 7, 2, 1, 0, right? So you have a lot of numbers, out of which the requirement is now you find out the sum of all the element in an array, but while you're finding it out, just sum the numbers only when the numbers are odd number. So 5, 7, 1. This is what I basically expect the output to be. So 7 plus 1, 8, 5, 13, right? 7 plus 1, 8, 8 and 5, 13. Yeah. So 13. So we expect 13 to be the output, is not it? Now, if you have such requirement, then what you will do? Again, you will end up writing some if condition here, is not it? Right? To check whether that number is even or odd. right? And you really don't have to do that in case of your Scala. All you will do is you will say array dot filter modulo 2 is equal to 1 dot reduce, something like this. It's done. One line code, right? And then you don't have to write a lot of code. That's what the whole agenda of telling you this, right? So it's okay. You don't understand a couple of things. That's fine. This is day one. This is not day end. It's just day one. And I just wanted you to understand what Scala can do for you in a very short way, right? And it's literally like when you compile this code into bytecode, they all gets converted into the same bytecode because it is the same JVM which is going to execute this two programs, right? So you have a Scala compiler which gives you which gives you a .class file. You have a Java compiler which gives you a .class file, and that's how it is. Okay. Now let us talk about what are a high level, benefit of using Scala. So I'll just quickly put some of the points about Scala, appreciating it more better. Okay. So let me also share my screen, guys, so that you can see my document, and then we'll move forward with that document every time. Okay, so I have just shared my document here, and I believe you are able to see my document now. Please check it out. So I'll be basically referring all this document. I have prepared this document, and whatever we are going to learn would be all from this document. Okay, I will not teach you anything out of the document. Any new concept that has come, first I'll document it, and then I'll teach you, and this document will also be available in our portal itself. Okay, so let's move on and let's understand what are the differences, right? So Scala versus Java in a nutshell at a very high level. Number one, pure object oriented language. Okay, so let me go back and I'll move on. So number one is pure object oriented language. Number one, pure object oriented language. Okay, now the problem with Java is not a pure object oriented programming language because of data types, because of primitive data types. In Java, what you have is you have 8 primitive data types, and these primitive data types are really not objects. Uh, they are just variables, right? So they are really not object. They are not an object of any class, right? You have a lot of other stuff like a plus, a minus, multiply, divide, right? All these are basically what operators. They are not methods. Okay. However, the reason why Java is not a primitive, Java is not an pure object-oriented programming language is because Java has 8 primitive data types. Okay. Whereas Scala says, I want everything to be object. Okay. So in Scala, there is no data type like integer, float. Instead, there is a class called int. This is a class, literally a class. Okay, and this float, you have a class called float. You do not have anything called data type in Scala. Okay, and everything is object. Like you think about anything. Operators are also like methods, right? So everything is just objects and methods, and nothing out of it. Nothing different than that. Okay, so everything what you see in Scala would be purely object-oriented approach. Everything is classes, objects, methods, and so on. That's the point number one. Now let's move on to my next point. The next point is your Scala supports both imperative style as well as functional style. What do you mean by imperative style? Imperative style means using the traditional loop, right, to get your work done. Functional style means you have a lot of functions available, and you can basically use some predefined functions to get your work done. Okay, or you might have seen in Java 8 it supports lambda expressions, right? You can write some sort of functional programming, but let me tell you, Java is not matured in functional programming. You cannot do a lot of stuff what Scala can do. Okay, I understand that you will tell me that, hey, from Java 8 it also supports functional programming, but it does not have a lot of APIs or a lot of functionality across. The moment you start understanding Scala, you'll really appreciate that Scala is very much advanced than your Java right now. Okay, so second point was it supports both imperative and functional style. So let me show you one example. I'll share my screen so that you can see. So let me just share my screen, and I'll tell you what exactly it is. Okay, now look into this. if I ask you to write a function, a small function which can give me the highest number from a list, all right, from an array or whatever you call. So ideally, you will be doing it in this way, right? So you'll say, okay, I got a list, array list, and then I'll iterate through this list and I'll try to find out what is my highest temperature. You'll use a loop, something like this. Okay. Whereas if you want to get it done in your functional style, you can just say temperature dot fold left, and you write some value here. I'll tell you how exactly it works later. Okay. But right now it's okay. You don't really have to understand this. I'm just trying to tell you how precisely you can actually write the code. Okay. Third point, operators are also of functions. So let's move to the third point. The third point says operators in Scala are also functions. This is very interesting. Okay, so let's talk about that operators. Okay, number two, we have already understood functional as well as imperative style of programming. Okay, now third is what operators, right? So Scala, functions. Sorry. In Scala, operators are functions. What do you mean by that? Very important. Okay, what do you mean by that? So suppose you want to add two numbers. How do you do that? In Java, you will say int x equal to 10, y equal to 20. Okay, and then you will say int sum is equal to x plus y. So what is this x? What is this plus, guys? This is an operator. This is an operator in Java. Okay. Same thing you want to do it in Scala. You write it like this. Well, x is equal to 10, y is equal to 20. This is not required. Semicolon is not at all required. Okay. And then you say, well, sum is equal to x plus y. Right? But then when you're doing this in Scala, okay, this x is not just an operator. You still call it an operator, but internally this is basically a method. What is a method? Function. Okay, and what is the function? Function or method is basically, I would say, executable block, right, within a class, right? So if you understand classes, objects, and all, you might know that that you have a class, let's say class demo, or let's say let's class, I'll say not sum, I'll say calculate, right? This is basically your class. And in this class, you basically write, mostly you write two things, right? One is member variables, right? The other one is your methods or functions, right? Like public, int, sum, int x, int y, okay, x plus y, return. This is what we call a function, right? Or a method. A method or function is basically a block which can be called from outside by using the object of it, right? So similarly, if you look into this plus is basically a method. Okay. Now, as we know that in Scala, you do not have a primitive type like int, float. They are all internally classes, right? So this x, when you say well x equal to 10, that means you're creating the object of integer type, int type. Okay. Similarly, when you say y, you're again creating an object of int type. So int integer is a class in Scala, and you have created two objects, x and y, right? And then you're saying well sum equal to x plus y. So this is an object. On this object, plus method is basically called. So this is basically equivalent to x. This is basically equivalent to writing x dot plus y. Okay, for example, suppose this is your calculator class, right? Now, if you want to call this sum method, what you have to do? You have to create the object of calculator. In Java, how do? You say calculator, calculate, okay? C is equal to new calculate. This is what you do in Java, is not it? And then you say C dot sum. And what will you pass? You pass x and y, right? So maybe 5 and 10. This is how you do. And what you get back is a sum, so you say int result. This is how basically you do, right? This is how basically you call your sum method. You say int result is equal to c dot sum 5 and 10. That's what you do, right? Now, if you see what is the sum, guys, this sum is basically what method, is not it? Method, or you call function, but we don't call function in Java. In Java, the same thing is called as a method, right? So C is basically what object of which class? Of calculate class. Of calculate class. Sum is basically a method. This sum is accepting two arguments, and those two arguments are integer, and which we have passed 5 and 10. Done. Now suppose if I write one more method called square, okay, so I'll say public int square, right, and I'll just say int num. And what is the logic to square a number, guys? Num into num, is not it? Yeah, num into num. So you'll say return num into num, right? That is what it is going to give you a square. But now let us try to understand, if you do a square here, how do you call it? You will call it like this, right? So you have already a C object created, C object, calculator C. You'll say C dot square, and what will you pass? You'll pass some number 5. What it is going to return you? 5 into 5, 25 is the result, right? But let's assume if this method name would have been plus, suppose, okay? Now, how would you have done that? You would have written it like this, is not it? C plus 5, right? That is what we are talking about here. Okay, so what I'm trying to tell you is, in Java, there's a class called int, integer class, like this, class int. Okay, now within that int class, there is a method called plus, like this. Okay, and hence, when you want to add two numbers, you basically say x plus y, but it is actually x dot plus method call plus method by passing y as a parameter. So this is actually what happens internally, but still you will still write it like this. You still call this as an operator. Okay, like in a generic word, we will always call plus is an operator, but internally under the hood they are really not just operators. They are basically the method of some classes. Okay, that's what Scala operators are. They are purely functions, right? So they're purely functions. The moment you use an operator, that basically is internally a function, and the function actually gets called. Okay. Now let me move on to my next like point. So we understood that. Now the next point is Scala is a static type language. So what does that mean? Okay. So we're just trying to understand all the features of Scala. What Scala can do at a very high level. We are definitely going to go in detail, understanding all this stuff one by one. So it's okay if you don't understand a lot of programming right now. That's fine. You should be able to improve that over the period of time. Now, the next point is what Scala is a static type language. Static type, number 4. Okay, static type language. What do you mean by that? Okay, so in Java, if you want to write, let's say, if you want to create a variables, let's say define two variables of integer type and do a sum. How do you do that? You will basically write it like this, right? So you'll say int x equal to 10, int y is equal to 20, right? And then you'll say int sum is equal to x plus y. This is what you do in Java, is not it? Now, here if you see, what is the type of x, guys? The type of x is integer. The type of y is integer. The type of sum is integer, because they are actually producing sum. All right, they are producing the sum of two numbers, and that's why we have this as integer. In Scala, it says, in Scala, like you don't really have to specify the type, right? You will just say, well, x is equal to 10, and your Scala compiler will understand that x is basically an integer type because you have just written 10, right? Similarly, if I say, well, y is equal to hello, right? Scala understands that y is basically a string because you have written them within a double quote, right? And then you say, well, result is equal to y plus x, right? So now Scala will understand that, hey, this is a string and this is an integer. String plus integer should not be an integer, of course, but it can be a string, right? So the result would be of string type. Now, this is what we call a static type language, wherein you really don't have to tell Scala what should be the type. Scala will be able to understand it automatically based on what you are actually returning. Is not this amazing, right? So Scala says, hey, you want to specifically say that it is an integer type, you can always use like this. Well, x of integer is equal to 5. You can still do it this way, right? But then Scala says, why do you want to do this? If I'm automatically giving you this stuff, why do you really want to write this line, right? And take more space or make your code little lengthy. Why do you want to do that? I can do it for you, right? So Scala says I can automatically interpret the type of the variable based on how you are using it, right? And that is what we call a static type language. Okay, so I hope you understood this. Let me move to the next point. Now the next point is Scala is strong and inferred. Scala is strong and inferred. So what do we mean by that? So it means it is almost same, right? So it means whenever there are anything which is getting executed, any expression that is executed, Scala will first interpret this and interpret this. So see the difference between these two, right? So static type language means Scala says don't write here the type, don't write here the type. Okay, it will be able to understand this based on what you are expressing, whatever you are assigning, right? So you say hello, it will understand that it is your string. Now, when we say strong and inferred, that means whenever you are executing any expression, it will be able to identify how it should be it should deal with that particular expression. So let me just go back to my notes. I'll say share screen, share the notes. We are actually talking about this. Okay, so Scala is a strongly typed language, which means data type is checked before performing operation. Well, result is equal to a plus b. It checks the data type of a and b before performing the operation, right? So whenever a or b is performed, see, you're trying to do an add, right? You're trying to do an add. So it says, okay, I want to do an add. So here on one side I have a string, and on the other side I have an integer. So what it does, it says, okay, I should go and check which method to be called, right? So probably string plus method, right? So in string class, there is a method called plus, which will actually do a concatenation for you. That's what it means, right? So inferred means it is smart enough to understand the resultant type. So once it has understood that, okay, this has to go and perform some operation, it will come back and say, okay, I'm going to perform some operation. Now the result type would be known to Scala. You really don't have to tell it to Scala. Okay. All right. Now, Scala can be mixed with Java library, and you can build an entire enterprise solution based in Java. This is very, very important, guys. We'll talk about that in some time. Okay. I'll go back to the next. Semicolon and parentheses are optional. Okay. So when you are writing a Java code, you know that every line should be terminated by what? A semicolon. It's not it. Whereas in Scala, it says, I don't really require, you see, when you write a code, you basically use this pinky, you basically use this pinky to type your semicolon all the time. Scala says, let us give little rest to your little pinky, because I personally believe that, typing that semicolon is useless and it should not be required anymore. So in Scala, it says, the new line is basically the, like the terminator, right? You really don't have to write a semicolon anytime. Right? So anytime you feel you have a complete line of code, it's okay. However, having said that, if you have two expressions written on a same line, then you can definitely use semicolon. Okay, semicolon using is not mandatory, but if you want to use it, you can still. But I have not seen anybody using it unless and until you write a lot of multiple statement on a single line. And even if you're writing that, I would still question you, why are you doing that? Right? So you should not write multiple expression on the same line. Try to write them on independent lines and avoid using this semicolon altogether. as well as the curly braces are optional. We will talk about that as we move on with the program. Okay, but right now I'm just trying to give you a very high level understanding on the difference between Scala and Java. Okay, next I have operator overloading is allowed. So in Java, if you see in Java, you have only plus operator that is overloaded. Okay, and what do we have overloading, guys? Method overloading. That means the same method can do two different operations, right? So if and when we say this plus operator is overloaded, in the sense that plus operator can be used to add two numbers, right? It is an operator, right? And then the plus method is also used world, right? So if you say hello plus world, then the output is hello world, but here also you're using plus operator, and this is also an operator, right? So if you see the same plus operator was able to add two numbers or concat two strings, and that's why we call in Java we use plus as the only operator that can be overloaded. But in Scala, you can have your own custom operators. You can do a lot of overloading. Okay, so we'll talk about that when we move more forward toward the functional side. Moving forward, let me go to my next functional programming. This is the beauty of Scala, where you cannot really compare Java as well. Java is still new, I would say, and a lot of the features in Java are implemented looking into the Scala in mind. Think about it, right? So Java came earlier, right? Java came earlier in the market, 1995, 1996. Scala is really new, 2004. But then the Scala has gone to a certain extent that a lot of features in Java, whatever comes, they also look into the Scala, because at the end of the day, they both are competitive to the same JVM. Everybody wants to survive, is not it? That's what. So Scala, Java is basically used as a function. Java is basically used as an object-oriented programming language. And whenever you say that I'm a Java developer to someone, people would feel okay. You can program using the object-oriented concepts, right? But then when you say you are a Scala developer, then there is a question: hey, are you a functional programmer or you are a same object-oriented programmer, right? So now Scala allows you to use either object-oriented programming concepts, or you want to go with the functional, you can also go with the functional programming language. Okay. Now there are so many functional programming language available in the market. You may say, is Scala the only one in the market? I would say no. There are so many other languages which are functional programming. So look into this example of functional programming languages. You have Haskell, Mercury, Scala, FSAP, Java since 8 supports functional programming language, Scheme, SML, Erlang, OCaml. So all these are basically what are functional programming languages, right? So we also have Java since Java 8. Okay, next, traits. So Scala supports a concept of traits, which is very, very similar to your interfaces in Java. Okay, like in interfaces, what you have, you basically define only the methods, and then you with no body, right? And then when you implement them, you basically implement the entire method of an interface. So likewise, we have traits in Scala. I'll not talk about this right now because you will not be able to understand it. I've just given this as a high level notes so that we can understand, but going forward, we'll be learning a lot. Okay. Easy programming to multi-threading. Java, if you look into Java, the biggest challenge is understanding the multi-threading program. Okay, because it's always a hard time for any programmer, including me, to understand a multi-threading program. It took me a lot of years to master that multi-threading concepts. Now, thanks to Scala, that Scala has a lot of other approach. In Scala, you can either use the Java threads as it is, or they have a lot of other approach to solve the problem of your threads and concurrency. We'll also be talking about that, but right now let us not go much in detail about this. Next, can use Java classes in Scala and vice versa. So if you want, what you could do is you could basically create a Java project. So what you could do is maybe you can do something like this. So say you want to create a project, so you can create a Scala project. Okay, so you create a Scala project, and in this Scala project, what you can have is you can have a Java code, you can have a Scala code. Your Scala code can be consumed by your Java code. Your Java code can be consumed by Scala, right? So it can work on both the approaches, right? So for example, you may say, hey, my team is already working on Java mostly, but since I'm little comfortable with Scala, can I do this, right? So I would say yes, you can also do that, right? Because what you could do is you can create your project using Scala, write all your pure Scala code, convert that into a jar file, and let your Java program consume this. Okay, that is purely possible. Now, since Java is quite used in the market, there are a lot of libraries available in Java. Okay, for example, suppose I have a requirement of uh, creating a PDF, or I have a requirement of creating Excel. You might have seen when you open your net banking, you want to, and if you want to download your statement, they give you an option. Do you want to create do you want to create the statement in PDF or Excel or some other version, right? So if you are given an option like this, then probably if I say that the whole algorithm is written on Java-based language, then most likely this PDF generation is done using iText. Okay, and this Excel generation is basically done on Apache POI, most likely. So iText is a library in Java where you can create a PDF file. You have also something called PDF. So either you would be using iText or the PDF box, third-party APIs, libraries, or if you want to deal with Excel, then most likely you use Apache POI. That's what you basically do in your Java projects. Now, if you are now writing a Scala program, and let's say in the Scala program, you have a requirement to use these libraries, but these libraries are what written in Java. It's not, they will be available to you as a jar file. Okay, they will be available to you as a jar file. So can I use this jar file in my Scala program? Yes, you can. Okay, that's the beauty, right? Because at the end of the day, they are both brother and sister. JVM. It's not it. So you have this jar file. This jar file contains dot class. Your Scala can easily understand dot class file, and that's what it is, right? So in Scala, what you can probably do is you can import this iText or PDF box using SBT properties or Maven, whatever works. We'll be using SBT. We will be integrating the dependencies here, right? Specifying the dependencies here so that the dependencies are all taken care of. And then you will just start using the classes of this uh, of these libraries. The only difference would be while you code, you will write all Scala syntax. You write all your Scala syntax. You will not write a Java syntax. Okay. For example, if suppose there is a class called demo in this whole jar file. In this jar file, let's say there is a class called demo. Let's say PDF demo. Okay. So PDF demo, and let's assume you need to create the object of this PDF demo to work with like the PDF concept. So if you do it on a Java project, then you'll say PDF demo PD is equal to new PDF demo. You'll do it like this, and then you'll say PD dot whatever method you want to call, right? That is what you basically do when you're doing it in your Java. But then, since you are going to use it on your Scala project, you will not write it like this. You will still write the syntax in your own language. Well, PD is equal to PDF demo, or maybe new also. It depends. Okay, and then you say PD dot call the method whatever you want to call. Right. So the syntax would only differ. Right. The syntax would only differ, whereas you can happily integrate your APIs. And there are a lot of libraries from Java because Java has been used in the industry since long time, right? Many people are using Java, so they have built a lot of libraries. And even if you're coming to Scala, you don't really have to worry because you can still use all those libraries, right? But then you cannot really use the libraries of Python, right? Nor Python can use the library of Java unless and until there are some web services exposed. But if you are working with Scala or Java, you can either change the libraries. A Scala library can be used in Java or vice versa. That is purely possible.